All right, so trapezoids. Trapezoids are a little more complicated to think about, but let's take a glance, okay? So we have area of our parallelograms, our base height, area of triangle is base height divided by 2. Now we have trapezoids. Trapezoids are interesting because trapezoids are quadrilaterals, but they are not parallelograms. They only have one pair of parallel sides. Okay? However, we can still use this shape and move it around to make something familiar and create a formula from that. So, when we're dealing with trapezoids, we have two different bases. Okay, we have base 1 and base 2. Okay, and that makes sense because they're two different lengths, so they're going to have two different names, base 1 and base 2. Base 1 and base 2 will both make a 90-degree angle with our height, right? And so let me give you the formula. The formula for finding the area is, area of a trapezoid is base 1 plus base 2 times your height divided by 2. Once again, like I said with the triangles, that's a weird looking formula. Like, it doesn't inherently, like, automatically make much sense. Let's go back to this fancy gizmo. This one. If I take a trapezoid and I double that trapezoid, what shape do I have? Anyone? Oh, wait, I'm not in the classroom, so I'm going to say it for you. I've made a parallelogram, okay? Once again, we know that the area of a parallelogram is described by base times height. So let's do that on here. If I double, that's a terrible line. If I double this trapezoid approximately, I've flipped it upside down and moved it next to it. So this is now our base 2. That's our base 1. Our height is still the same. So our height here was 1, 2, 3, 4, 5. Our height here is still 5, okay? It's the same thing. Still makes a 90-degree angle with our bases, and it's still 5. All right, but now what we have is one big, giant parallelogram. And so if we wanted to describe the area of this parallelogram, well, it would be our base times our height. However, look at what the quote-unquote base, that was terrible, I apologize. The way we describe our base of this giant parallelogram would be base 1 plus base 2. And the way we would describe the height is just the same as our original height, so h. But once again, just like with the triangle, okay, just like with the triangle, I apologize, just trying to switch between all the things. Just like with the triangle, we don't want the area of this parallelogram. We want just the area of our original triangle. Okay? So to do that, we had to take the base and the height and divide by 2. It's the same idea here. We don't want the area of this entire parallelogram. We just want the area of our original trapezoid. So we need to take whatever the area of our parallelogram is and divide it by 2. And so that is how you get the area of the trapezoid formula. So you're either going to see it like this. You're either going to see area equals base 1 plus base 2 times height divided by 2. Or you're going to see area of our trapezoid equals base 1 plus base 2 times h times a half. All right, so half of base 1 plus base 2 times height. Once again, these mean exactly the same thing. All right, I'm going to show you one example. I'm going to show you one example, and we're going to be done for the day. And I have all of this written on here for you to look at again. So if I have this trapezoid right here, once again, our area formula is base 1 plus base 2 times h divided by 2. So I've labeled everything. My base 1 is 16 centimeters. My base 2 is 8 centimeters. So I did 8 plus 16 times our height, which makes that 90-degree angle. So times 6 divided by 2. I simplified. So we have 24 times 6 divided by 2, which is 144 divided by 2, which is 72 centimeters squared. All right, I'll let y'all try a few on your weekly slides, okay? Bye-bye.